Hello friends, today in this lecture we will see the metric space. Now in this metric space, first we will see the introduction of the metric space, definition of the metric space and their example. Now the introduction of the metric space. First we will see some definition, that is definition of absolute value function on R. Let f from R to R be a function defined by f of x equals to mod of x, that is equals to x if x is greater than 0, and that is equals to minus x if x is less than 0 and equals to 0 if x equals to 0. This is the definition of mod function. Now the properties of the absolute value function, mod function or absolute value function को इसको बोलते हैं. Now the first property is mod of 0, that is equals to 0, that is absolute value of 0 is 0. Absolute value of a is always greater than 0 if a is not equals to 0. Absolute value of a equals to absolute value of minus a. Then absolute value of a plus b is less than or equals to absolute value of a plus absolute value of b. That is triangular inequality. Now for x comma y real numbers, the geometric interpretation of mod of x minus y is the distance from x to y. This is the geometrical interpretation or geometrical meaning. If we define the distance function by rho, that is rho of xy equals to mod of x minus y, or sometimes some authors define by d of x comma y, that is equals to mod of x minus y. Some author replace rho by d also, that is distance. Then the properties of 1 to 4 have the following consequences for any point x, y, z be real numbers. Now the fifth property, that is distance x to x, that is equals to mod of x minus x, that is 0. That is the distance of the same point to itself. Point to itself is always 0. Now the distance of x y is always greater than 0 when x is not equals to y. The distance between two distinct points is strictly positive. Now the distance of x comma y equals to distance of y comma x, that is distance from x to y is equal to the distance from y to x. This is obvious. Now the eighth property, that is distance of x comma y is less than or equals to distance of x to z and distance of z comma y, that is triangle inequality. Distance function satisfies fifth to 8 properties. A distance function is usually called metric. If other distance formula satisfies the property 5 to 8, then it is called a metric. Now the definition of metric. Let M be any set. A metric for M is a function to distance rho with domain M cross M and range is contained in semi-closed interval 0 to infinity, such that for any element x, y, z of set M, that is distance x to x 0, distance x to y is positive, distance x to y equals to distance y to x, and then distance x comma y is less than or equals to distance from x to z plus distance from z to y. If distance rho is metric for M, then order pair M comma rho is called a metric space. If rho is the metric, if rho is the distance and metric for M, then the order pair M comma rho is called a metric space. A metric for M thus has all properties 5 to 8 of the distance function mod of x minus y for R. Now the example, f from r square to r be a function defined by f of xy equals to mod of x minus y, then f is a metric for r. This matrix is known as absolute value metric. Now the example, the discrete metric is defined by the formula d of x comma y equals to 1 if x is not equals to y, and equals to 0 if x equals to y. By the definition of d of x comma x, that is the distance from same point to itself, equals to 0. If x is not equals to y, then distance from x comma y equals to 1, which is greater than 0. Clearly distance of x comma y equals to distance of y comma x. Triangular equality, distance of x comma y is less than or equals to distance from x to z plus distance from z to y. If x equals to y, then the left hand side is 0 and the inequality continually holds. If x is not equals to y, then the left hand side is equals to 1. Since x is not equals to y, we must have either x is not equals to y or else x is not equals to y. Thus the right hand side is at least 1 and the triangle inequality holds in any case. Now the examples for the plane r square with the usual distance measured using the Pythagoras theorem. Distance from x comma y1 x2 y2 equals to square root of x1 minus x2 square plus y1 minus y2 square. This is sometimes called the 2 metric D2. This is also metric space for R2, that is 2-dimensional space. Now z equals to x1 comma y1, w equals to x2 comma y2. Now example, the same picture will give metric on the complex number c interpreted as the organ diagram. In this case, the formula for the metric is now d distance from z to w equals to mod of z minus w, where the mod is the formula represent the modulus of the complex number rather than the absolute value of the real number. Example, the plane with the taxi cab metric, that is, this is also the example of metric. Now the plane with the supremum or maximum metric, distance from x1 y1 x2 y2, that is maximum of x1 mod of x1 minus x2 comma mod of y1 minus y2, it is often called the identity metric, that is d, that we have shown in the figure. Now the example of not metrics means some example which are not metric, which not satisfies the definition of metric or properties of metric. Now rho equals rho from r to r be a function defined by rho of x comma y equals to 0, then rho is not a metric since 1 is not equals to 2, but distance from 1 to 2 equals to 0. By definition of rho, other properties are satisfied. Therefore this is not a metric because the first property is not satisfied there. Now again the second example which are not a metric, the plane with the minimum function distance from x1 y1 x2 y2 equals to minimum of mod of x1 minus x2 comma y1 minus y2, then d is not a metric since distance from 1 comma 2 comma 1 comma 5, minimum of 1 minus 1 2 minus 0, that is minimum of 0 comma 3 equals to 0. Second property is not satisfied. Therefore this is not satisfies all the properties of metric. Therefore this example is not a metric. So friends, we have seen here the metric space with example where some examples are the satisfies the condition of metric and some example which are not satisfies the condition of metric, that is the condition from 5 to 8 properties satisfied, then that example we can say that this is the metric. Thank you. So in this lecture we have to stop here. Thank you very much.